Hello everyone, this is Shiva. In the last problem, we've seen the continuous body, a uniform straight rod, or thin wire or thin rod of finite length, and we have also seen cases where it goes to infinite, right? On one side, on or both sides, 90, or both angles could approach 90, depends on whether it is infinite or semi-infinite. So now let's see for an arc of radius r, right? So if I take an arc here, right? So this is our arc, and this is, let's say this angle is 5 by 2, this is 5 by 2, right? So the total angle subtended by the arc at the center is phi, right? And this radius of the arc is r. So I could calculate here the center. So instead of that, what I'll do, I'll take a general case where I'll do it on axis, just like for the total ring. So if I take the axis here, right? And by the way, this one, this is not in this plane. You could consider, okay, since I can't draw that, you could consider the arc to be in this plane, right? Like this, arc is like this, and yeah, this is the axis. So here is the considered point. So this is the axis here, excuse me, this is the axis here. So somewhere at this point, if I consider some arbitrary point P, right? So if I consider some element, some small element, normally while we derive at the center, so this is a considered element. So let's say this angle is some d theta, right? From here this is theta. So since this is vector, the small electric field due to this one in this direction would be dE in this direction. Since this is theta, this angle would also be theta here, and the component in this direction would be dE cos theta, and in this direction would be dE sin theta. This is usually how we do, right, when we find the electric field at this point, at the center of the arc, right? So in the axis also, if I consider, I mean not exactly same, so if I consider this small element here, the approach is kind of that of a ring, the small element we consider at the topmost point, and exactly at the diametrically opposite point we consider the same element, right? And we join these two, and there we see only electric field component in this direction. All the transverse components, these components up and down, they'll cancel each other out. But here this component will also be there, we'll see that. So here, so for example, this is the component here. So if I consider this small element and the considered point here, so this would be in this direction, right? So small, so this is radius r, and this is x, and this is our actual hypotenuse, so this would be root of x square plus r square, right? Okay. Yeah, so due to this small element, small electric field in this direction is dE, and let's say this angle is some other angle, so this is, let's say, alpha, right? Okay, here we took phi and theta. Okay, this is alpha, so this would also be alpha, and this would be d cos alpha and this is dEsin alpha. I have to traverse this component so that it should cover the whole arc. Since the considered element is making an angle theta here, so actual direction d is in this direction, so this is dA cos theta. So actual direction, if I take here, so this one would be so the d sin alpha cos theta term is not the one which is written there. It is the one where it is pointed with the black arrow mark, and it is the projection of projection. So that one is actually d sin alpha, and theta is there. So the component of d sin alpha would be d sin alpha cos theta, and that is the one where arrow mark is showed. So the component in the direction where arrow mark is showed, that gives us the total electric field in the y direction. You could ask, what about the other component d sin alpha sin theta, which does not contribute to the AY, because the only thing which contributes is d sin alpha cos theta. So if I vary the element, that theta changes. In that direction only we took the total component. So to get the total y component, we should integrate d sin alpha cos theta. So if I do this one, so that is, let's say this is again Ex and this is Ey. So Ex component integral d cos alpha. So integral d, by the way, so k small dq by distance square into cos alpha, Ex. So Ax is equals to integral k dq. So dq again, so if I take since one dimensional, I'm taking line charge density, lambda is equals to dq over dl plus dq is equals to lambda dl. So small charge dq is equals to lambda into length of the small element. Length of the small element, this one, so that is length of the arc r theta, so that is r d theta. Right. So we have dq as r d theta divided by r square. The distance square between the considered element and the considered point, right? So square of this one, so that would be x square plus r square into cos alpha. So from this cos alpha, adjacent, that is x divided by x square plus r square whole power 1 by 2. Right. So Ex is equals to k r. Well, I'm taking x as it is, so x d theta divided by x square plus r square whole power 3 by 2 integral. Right. So yeah, all of these are constants. So k r x divided by x square plus r square whole power 3 by 2 integral d theta. Right. So the x, the fixed distance, I'd considered at some particular point x is constant. The radius of the arc, that is not also changing, so x and r terms are constant. The only thing, this element is traversing here, so this theta is changing from minus 5 by 2 to plus 5 by 2 here. So minus 5 by 2 to plus 5 by 2. So Ex is equals to krx divided by x square plus r square whole power 3 by 2. So integral d theta gives us constant theta, so going from minus 5 by 2 to plus 5 by 2. So krx divided by x square plus r square whole power 3 by 2. So 5 by 2 minus of minus again plus, so 5 by 2 plus 5 by 2 gives us 5. Right. So this is our Ex, right, which is in the axis in this direction, Ex component. So the same thing, this gives, this makes sense, like for example, if I consider the total element, total ring, right, So our phi, the angle, that would be total 2 pi. Mass density here. So this one, small charge, that is lambda r d theta. Here dq is lambda d theta. So there's a lambda term here. Yeah. So for the complete ring, if I take phi as 2 pi, right, 2 pi r lambda, which is the total charge of the ring, which is the standard result which we know, that is kqx by x square plus r square whole power 3 by 2. Right? So this is for the arc at its axis. So now, so as for this term, let's do this one. So this is d sine alpha cos theta. Right. So other component in the y direction ay is d sine alpha cos theta term. So dE, we have k dq by r square sine alpha cos theta, that is equals to integral k dq term. So dq is small charge, right, for this one, which we already seen, that is lambda r d theta. So lambda r d theta by r square, actual distance between the considered element and the considered point, square of this one, so that would be x square plus r square, to sine alpha. Sine alpha from this triangle opposite by hypotenuse, that is r by x square plus r square whole power 1 by 2 into cos theta. So this gives us k lambda r square cos theta d theta divided by x square plus r square whole power 3 by 2, which gives us k lambda r square divided by x square plus r square whole power 3 by 2 integral cos theta d theta. By the way, the theta, this things goes from minus 5 by 2 to plus 5 by 2. So which gives us k lambda r square by x square plus r square whole power 3 by 2 cos integral cos sine minus 5 by 2 to 5 by 2, which in turn gives us k lambda r square by x square plus r square whole power 3 by 2. At upper one, sine 5 by 2 minus of minus, as we've seen in the previous one, right? So which gives us sine 5 by 2 plus sine 5 by 2. So that is equals to 2k lambda r square by x square plus r square whole power 3 by 2 sine 5 by 2. So this is our EY. Right? So if you see here, I mean, if I take this point here, that means x becomes 0 at the center, right? If I put x is equals to 0 here, so EY is equals to 2k lambda r square divided by x0 r square, square will cancel, which gives us r cube sine 5 by 2. R gets cancelled, which gives us 2k lambda by r sine 5 by 2, which is the one for an arc at its center. Right, electric field for an arc at its center, 2k lambda by r sine 5 by 2. This is a more general one, right? 2k lambda r square by x square plus r square over 3 by 2 sine 5 by 2. I mean, you don't have to remember this. But I guess this is a subtle point here, that is, you cannot directly take dE sine alpha here. I've also done the same, but instead you have to consider this theta also here, when we consider the electric field in this direction, right? I mean in this plane, not in this plane, in this plane. So there is dE sine alpha cos theta term, that is